Good morning, grade 10. Today we will start the first lesson in the fourth quarter, which is proportional parts of a triangle. Let's see here. We have theorem 1. If a line is parallel to one side of a triangle and intersects the other two sides, then the triangle formed is similar to the original triangle. Let's read it again. If a line is parallel to one side of a triangle. So we have here BC, this line is parallel to one side of a triangle. And this line intersects the other two sides, as we see here, line BC intersect the other two sides, AD and AE. Then the triangle formed is similar to the original triangle. The triangle formed here, I mean triangle ABC, the small triangle here, is similar to the original one, which is ADE. So here, from our theorem, if we have a line BC, and this line parallel to one of the sides of a triangle, and also this line intersect the other two sides, as we see in the figure, so we can say that the small triangle formed, this one, ABC, is similar to the original triangle ADE. And similarity here means that these two triangles are similar, means that each two corresponding angles are equals in measure and they have proportional, their sides are proportional. So what does it mean? Their sides are proportional. They have the sides, the corresponding sides, they have the same ratio. The same theorem here, proportion theorem. This theorem, also I can write it in another way that, let's read. If a line parallel to one side, if a line like this line TU, parallel to one side of a triangle, as we see in the figure, and this line TU intersect the other two sides, this line TU intersect the other two sides, as we see in the figure, then as we see, this triangle, the small one, is similar to this triangle. Or we can say in another way that it divides the two sides proportionally. And we said that proportionally means same ratio. So let's see, how can I translate the word proportionally mathematically? So here we have this side, TU is parallel to QS. So we can say that the ratio between RT to TQ, this is the first ratio, equals to the ratio between the other two sides, RU over US. So again, RT over TQ, this the first ratio, equal to the second ratio, which is RU over US. Also, we have here another proportional. It will be written in this form. So let's read it and understand it well. The first ratio is RQ, and I took here the whole side, RQ. Of course, who can tell me what is the corresponding side here? RQ over RT, RQ over RT, equals to the second ratio. Who can tell me what side is corresponding to RQ? RQ here. The corresponding side to RQ is RS. Very good. So RQ over RT, RQ over RT equals RS over RU. So these two ratios are equivalent. So let's see the third ratio. We have a third ratio here, which is RQS, which is the third side, QS over TU. So let's read the proportional again. RQ over RT equals RS over RU equals QS over TU. So from our theorem here, we learned that if we have two sides are parallel, of course this theorem inside a triangle, if we have two sides one side is, or one line is parallel to one of the sides of a triangle, and this line intersects the other two sides, so it divides the two sides proportionally. And we said that proportionally means same ratio as we see here. Let's see. Here we have a triangle, and we have here VW is parallel to RT. VW is parallel to RT, and this is the parallelism. Triangle SVW, the small one, is similar to triangle SRT as we see. This is from our theorem. So let's complete this proportion. ST, the long side, or the whole side, ST over SW equals, what is corresponding to ST here? Yes, sure, SR. So ST over SW, this is the first ratio, equals to the second ratio, which is SR over, who can tell me over what? SV, excellent. SV. Here is the answer. Another exercise. We have here a triangle ABC. In this figure, or in this triangle, we have GH is parallel to BC. So from this figure, I can say that I will use my theorem. I have a triangle, and I have here a line is parallel to one of the sides. So this triangle is similar to the original one. Or we can say that the sides, the two sides here, divided proportionally. Here, in this example, I want to find the value of x, this part. Okay, so I can use my theorem. So I can say that our ratio is 3 over x equals 4 over x plus 5. So I wrote here the length of each line segment beside the line segment. So the first ratio is between the sides is 3 over x. This is the first ratio, equals to, I will start with 4 over x plus 5, because 3, the corresponding side to this side is this side. So 3 over x equals 4 over x plus 5. So from this proportional, it's very easy to find the value of x. How? By using, very good, excellent, I can hear you. By using cross multiplication. So here I will make cross multiplication to this proportional to find the value of x. So 4 times x equals 4x. And 3 times x plus 5. 3, of course I will open bracket, x plus 5. Let's simplify our equation here. So 4x, I wrote 4x as it is, equals, let's multiply 3 by x and then 3 by 5. 3 times x equals 3x. And 3 by 5 equals 15. Here I have an equation, so I can solve it easily. So 4x here minus 3x will be x. And here the final answer will be x equals 15. So the length of this side equals 15, and I found the value of x. We can use our theorem as application in our life, like this example. And he needs to find the length of the brace here in our figure. We have here, this is a roof, and the height of the roof is 4 feet, and this distance equals 4, and the whole distance here equals 10, and we want to find the length of the brace here, this x value. So from the figure here, we can say that this shape, it's like our theorem, it's a triangle, and this side is parallel to this side, so we have here the parallelism, which is the condition in our theorem. So we can say that this side, because this side is parallel to this side, so the sides here divide proportionally. So the first ratio I will use, which is 4 over the whole side 10. Or you can say 10 over 4 as you want. So 4 over 10, this is the first ratio, equals, let's see, as we start with the small part of a triangle, the second ratio I must start with the small part. So I can say 4 over 10 equals 4 over x. No, start with the small part over the long part as we start here. Also the second ratio I must start with the small part over the whole part. So here 4 over 10 equals x over 4. Of course, nothing I will use start here. I will not use any dimension here because I don't have any length here for the other two sides. So I will use a part of my proportional. So I will start here with this side over the whole side, and I will start with this side over this side. So I have here two ratios are equals, and we can find the value of x by using cross multiplication. So here 10 times x equals 10x, and 4 times 4 equals 16. Of course, by dividing by 10 both sides, so the value of x equals 1 and 3 over 5 feet. So the length of the brace here equals 1 and 3 over 5. Let's start to solve this sheet together as a classwork. Prepare your pen and your copybook, and let's see how can we solve and how can we find the missing length in the following triangles. Let's see, here we have the first two examples. Here I have a triangle, and our question here, I want to find the missing length in the following triangles. So we have here triangle, and as we see here, the red arrows means that these two lines are parallel. So of course, when I see this figure, I can remember that I will use my theorem, and we can say that the sides here will be divided proportionally. What does it mean again, proportionally? They have the same ratio. So let's see كده. Who can tell me? Yes, I can hear you. We can say that the ratio will be, the first ratio is 16 over 12 equals, I can name this missing part with a question mark with x over 27. So I wrote here the first ratio equal to the second ratio, and now it's too easy to find the missing variable x by using cross multiplication. So by using cross multiplication, the value of x equals 16 times 27 divided by 12, which is equal to 36. So the length of this part will be equals to 36. Let's see example 2. Also here, we have here the length of the whole side equals 24, and this side equals 15. And the length of the whole side here is missing, and this small side is 25. And we can see the parallelism here, so we can use theorem 1. So we can say that the first ratio is, yes, very good, I can hear you, I can start with the whole side. Here I took the parts only, the part of a part. 16 over 12 equals x over 27. Here I will use the whole side, so it's correct also. So 24 over 15 equals, the whole side here. Do I know the whole side or it's missing? No, it's missing. Very good. So I can name it with x, y, whatever you want, any variable, over 25. I wrote here the two ratios, so it's very easy to find the value of x by using very good cross multiplication. So to find the value of x, I will multiply 24 by 25 divided by 15, and the value will be equals 40. So the whole side here equals 40. Who can tell me this side, this small side, will be equals to, who can tell me equals to what? Very good, I can hear you. Equals 15 because the whole side here equals 40 and this part equals 25. So I can find this small part by subtracting 25 from 40, which is equal to 15. Another example. Let's see here. I have another triangle. This triangle, I can see also the parallelism here. And I have the length of this part, and this part, and this part is missing, and this part equals 18. I want to find the value of this side. Also, I will use theorem 1. So we have here 20 over 5 equals x over 18. I wrote the proportional here, and then it's easy to find the missing variable. So x equals 20 times 18 divided by 5, which is equal to 27. So the length of this side equals 27. The second one, here we have this length equals 15 and this side is missing. I can name it with x. The whole side here equals 12 and this side equals 2. So who can tell me here? You can take a time to think about this question. Very good. I can start with 15 over x over 15 equals. I start here with 15, this side. So of course the corresponding side to 15 is this part. But I don't know the length of this part. So what I will do, of course, I know here the whole side equals 12 and the small part here equals 2. So of course this side will be equals to 12 minus 2 equals 10. Very good. So this side equals 10. So I wrote here 12 minus 2 over the small side. What is the side corresponding to this missing part? 2. So here let's simplify our proportional. 15 over x as it is. So 12 minus 2 equals 10 over 2. Now I have cross multiplication here to find the value of x. X here equals 15 divided by 5. So the value of x equals 3. The last two examples. Also here we have the same shape for our theorem, triangle and a parallelism here. And we know that the sides will be proportional. So let's see the first ratio of the first two sides. Very good. 5x over 45. Also you can start with 45 over 5x. Correct. But as you start with the small part in the first ratio, you must start with the small part on the second one. So here we start with 5x over 45. So I will say very good. 20 over 36. I can say 36 over 20. So 20 over 36. Let's simplify here by cross multiplication. 5x here equals 45 times 20 divided 36. 5x equals 25 by dividing by 5 both sides. So the value of x here equals 5. The last example here, we can say that the whole side here equals 28 and this side equals 8. This side equals 3x minus 5 and this side equals 10. As we see here, I don't have here the length of the whole side as we have on the other side. So we can get the answer or the length of this side, this part, by subtracting. Very good. So here the whole side is 28 and this part is 8. So the length of this part equals, very good, I can hear you, 20. So we can say that here is 20. Let's write now our ratio. The first ratio is 20 over 8. Very good. Who can tell me the second ratio will be? Start from here. 3x minus 5 over 10. Very good. Let's start here to make a cross multiplication. So here 200 equals 24x minus 40, and 24x here equals 200 plus 40 equals 240. By dividing by 24, the value of x here equals 10. So this x here equals 10. So who can tell me what will be the length here? Oh, is it 10 here? This side will be equals to 10? No. Only the value of x here equals 10. So by substituting the value of x, I can get the length of this side. So here, if x here equals 10, as we said in the example, so 3 times 10 equals 30. 30 minus 5 equals, very good, 25. So the length of this part will be 25. Thanks for listening, Britain. Inshallah, our homework will be booklet page 116 and page 117 from exercise 1 till exercise 6. Thanks for listening and have a nice day.